well-defined objects. The set of positive integers from 1 to 10, or the set of Prime Ministers of India, or the set of natural numbers. Finite set is a set containing countable number of elements. Example, set of natural numbers up to 10. Infinite set, the set of integers is an infinite set. Null set, a set containing no elements. Singleton set, a set containing only one element. Equivalent sets, two sets containing equal number of elements. Equal sets, two sets are said to be equal if each element of one set is in the other set and vice versa. Subset, a set A is said to be a subset of B if every element of A is an element of B. It is denoted by A is subset of B. Proper subset, a set A is said to be a proper subset of B if every element of A is element of B and there is at least one element in B which is not an element of A. Note, number of proper sets subsets of a set containing n elements is 2s minus 1. Number of non-empty subsets of a set containing n elements is also 2n minus 1. Number of not empty subsets non-empty proper subsets of a set consisting of n elements is 2 power n minus 2. Union of sets. The union of two sets A and B is set of all those elements which are either in A or B or both, and is defined as A union B. A union B is a set of all x such that x belongs to A or x belongs to B. Now sets. The intersection of two sets A and B is defined as a set of all those elements which are in both A and B, and it is defined as A intersection B. A intersection B, set of all x such that x belongs to A and x belongs to B. Disjoint sets. Two sets A and B are disjoint if there is no element which is in both A and B. Complement of a set. If A is a subset of the universal set X, then the complement of A with respect to X is the set of all elements of X which are not in A and is denoted by A complement. So A complement is a set of all x such that x belongs to X and X is not in A. the difference of two sets A and B is the set of all those elements of A that are not in B, or which are not in B. The difference of A and B is denoted by A minus B. In set notation, it is set of all x such that x belongs to A and x does not belong to B. So if I say A is 1, 2, 3, 4, 5 and B is 3, 5, 6, then A minus B will be 1, 2, 4, set of all elements in A but not in B. Complement of a set. If A is a subset of the universal set X, then the complement of A with respect to X is defined as the set of all elements of X which are not in A and is denoted by A complement. So A complement is set of all X such that X belongs to capital X and X is not in A. N of A union B is equal to N of A plus N of B minus N of A intersection B if N of A intersection B is not a null set. And also it can be given as N of A minus B plus N of B minus A and plus of N of A intersection B. Also N of A union B is N of A plus N of B if the intersection is a null set. If we look into three sets, N of A union B union C is N of A plus N of B plus N of C minus A intersection B and N of B intersection C, N of C intersection A and plus N of A intersection B intersection C. If you want to represent in Venn diagram of two sets A and B, so this part will be A minus B, right side will be B minus A, in between will be A and B, which is represented. It's called Venn diagrams. To understand and illustrate the relationship among sets, we represent them pictorially by means of diagrams. The universal set U is represented by rectangular region and each of the subsets closed bound spaces, normally circles. So we are representing, supposing I have X and Y. Outside totally is X. This part is only X and this part is only Y, and in between X and Y followed as both. So we give an example. In an examination, 60% passed in maths, 50% passed in English, and if 20% failed in both, find the percentage passed in both. We are looking at the past candidates. You have maths here and English here. Maths is 60% right outside, English 50% outside. The both is a space intersection, call it as X. We are given 20% failed in both the examination. So that means overall pass percentage is only 80. So if you look at the diagram, only maths is 60 minus x, only English is 50 minus x. So 60 minus x plus x plus 50 minus x will add up to 80. So 110 minus x is equal to 80, or x is equal to 30%. B and C. This place is only A, this is only B, this is only C. We have exactly A and B, exactly B and C, exactly C and A. We have all three. So you'll find there are 7 places. If you fill up these places, you can answer any kind of questions. Let us take an example. In a college of 10,000 students, it was found that 40% students opt for electronics, 20% students opt for communication, 10% students opt for computers, 5% students opt for both electronics and communication, 30% student opt for communication and computers, and 4% opt for electronics and computers. If 2% of the students opt for all the three, then the number of students who opt only for electronics is 3,100, 3,300, 2,900, 1,400. And marking one side as electronics, other circle for communication, third one for computers. You know the percentage below that, 40% for electronics, communication is 20%, and computers 10%. Let us first look into all three. 2% student opted for all three, so 2% you write in between. Then when he says 5% of students opt for both electronic and communication, out of which 2 is gone, so remaining 3 you have to write where electronics and communication only. Then 30% communication and computers, 2% gone, so 28 you will write. Can't be 30%. This is a mistake, I think it should be 3%, so let us write 1% here. And 4% electronics and computers, so the remaining 2% here. So you can try to fill up only electronics. So only electronics will be 7, so 33%, and 6 gone, 14% will be only communication, and 5 gone, 5% will be only. So we can write now only electronics will be 33%. So number of students opting for only electronics will be 33% of 10,000, that must be 3,300. In sum you have to make a correction of students opting for communication and computer is only 3%, not 30. That sets it right. So from this we can answer a number of questions. If I say number of students opting for exactly 2 subjects will be 3 plus 1 plus 2, that will be 6% of 10,000, that will be 600. Number of students opting for only 1 subject will be 33 plus 14 plus 5, that will be 62% of 10,000, which will be 6,200. So we can say any number of questions can be asked during looking at the numbers in the diagram.
Sets are given. One is x is equals to 8 to the power of n minus 7 minus 1 where n belongs to n, and y is multiple of 7. So that is we require here, let us take n is equals to 1. So because this natural number starts with 1, so the first element in x can be written as 8 to the power of 1 minus 7 of 1 minus 1. Nothing but 8 minus 8 is equals to 0. So let us take again another number from the same natural numbers, that is n is equals to 2. It gives 8 to the power of 2 minus 7 of 2 minus 1 is nothing but 64 minus 14 minus 1 is 49. So all the values we are getting of 49 into a number, that is nothing but lambda we are getting, and here y set is multiples containing all the multiples of 7 like 7, 14, 21 and all this it contains, and here this 49 lambda is a subset of this y, so therefore we can write x is subset of y. So option A. Question, 2 sets are given containing 3 and 6 elements respectively. That is, we can write n of A is equals to 3 and n of B is equals to 6. Now what we require? We require the minimum and maximum number of elements in A union B respectively. So we know n of A union B is equals to n of A plus n of B minus n of A intersection B. Here n of A union B is either minimum or maximum, as n of A intersection B is maximum or minimum. So we are taking the, first of all, let us take n of A intersection B is minimum. That is, we can write it as n of A intersection B is equals to 0. So the above principle, n of A union B, can be written as here. Already we know the value of n of A is 3 and n of B value is 6 minus, already we are getting this n of A intersection B as 0. So is nothing but 9. So therefore maximum number of elements in A union B is 9. Next we are taking n of A intersection B is maximum. When it is possible only for A is subset or equals to B. So automatically the least number, that is 3, happens here for n of A intersection B, that is n of A intersection B is equals to 3. Therefore again n of A intersection B, n of A union B can be written as n of A is 3 plus n of B is 6, and now we are getting n of A intersection B as 3. Nothing but 9 minus 3 is 6. So therefore minimum number of elements in A union B is 6. So the answer goes to option A. Above problem, a set AN is given like set of AX is nothing but such that X belongs to N. Now already given that BN intersection CN is equals to DN. So we require D. For that we will write first of all BN. BN can be written as same BX such that X belongs to N. What this is? Nothing but set of positive integral multiples of B. Even we can write the same Cn as set of Cx and X belongs to N, nothing but set of positive integral values or integral multiples of C. Now already given what it is, Bn intersection Cn is nothing but Dn. What it is? This is nothing but set of positive integral multiples of both B and C. Here the word we are using intersection. Intersection is nothing but the common multiples. So common multiples can be given as Bn intersection Cn is equals to some Kx and X belongs to N. Already we used the word common is nothing but where K is LCM of B and C. Hence we can write Dn is nothing but LCM of B and C. So the option B is the right answer here. Given of P is a set of all the determinants of order 3 with entries 0 and 1 only. And Q is the subset of P consisting of all determinants whose values is 1. And even given here, let R be the subset of P consisting of determinants whose value is -1. then what we have to do here? We have to select one of these options. We know the determinant changes by minus. When it will change? By interchanging rows any two or columns, even these are also any two. Then what it happens, the determinant changes, the determinant value changes to minus. So what we can write here, corresponding elements to every element in determinant of R obtained by interchanging these rows, any two rows. Let us take adjacent rows or columns. So therefore we can write n of q is subset or equals to n of r, and even we can say the number of elements in q less than or equals to n of r. So similarly we can write n of r is less than or equals to n of q. So therefore this is possible only for n of q is equals to n of r. That is what we can write here, q has as many elements as r. In the given question he is asking about the number of elements. We know that P of phi can be written as set of phi. So this implies P of set of phi can be written as set of phi, and again set of phi we can write here. And again in the next step, if we require P of phi. So in the previous set we are containing two elements, and this becomes the first element will be phi and second element will be same set of phi. Third element will be set of phi, and fourth element will be phi comma set of phi. So therefore we are finding in the previous set 4 elements. So we can write n of P of phi is 4, and the option is C. Previous question, one more question is given here. Find the number of students who opt only for communication. That is, we require here n of A intersection, n of A dash intersection B intersection C dash can be written as n of B intersection A dash intersection C dash is nothing but n of B intersection A union C whole dash, and the formula we can write it as n of B minus n of B intersection A union C. From distributive law we can write here n of B intersection A union B intersection C, and from the formula we can write it as n of B intersection A plus n of B intersection C minus n of B intersection A intersection C. So what is given here, n of B already we have 2000s minus n of B intersection A is 500 plus n of B intersection C is 300 and minus 200. It gives 2000 minus 600 is nothing but 1400, and the right answer is B. Given for a singleton set and 4 options are given. First of all, singleton set is nothing but a set containing a single element. Let us cross check the options here. First of all, taking B set, what is given in B set? Modulus of x is equals to 6 and x belongs to Z. Modulus of x is nothing but 6 means x can be plus 6 or minus 6, and these belongs to Z. And here we are getting 2 elements, which is not the correct answer. Second one is C option. We are taking that x square plus 2x square plus 1 is equals to 0. 2x plus 1 is equals to 0 is nothing but x plus 1 whole square is equals to 0, and this implies x is equals to minus 1 comma minus 1, and which are doesn't belongs to n here. So even C option is not correct. Next, x square is equals to 7. Here x value becomes plus or minus root 7, which doesn't belongs to n. So D option is also not correct. So automatically the option should be A. Let us check A also. Modulus of x is equals to 5. This implies x should be plus 5 or minus 5. But what is given? X belongs to n is given. So 5 belongs to n is only one element, which is nothing but a singleton set. So the option is nothing but A is our correct. Given that group of honest persons is, first of all, a set is nothing but well-defined collection of objects. Here honesty cannot be defined, so we can say it does not a set. So that is, we can say honesty is a subjective term, so we can say it's not going to be a set. So the option D is correct here. Given that a quality control board checking of sample TVs of here 1000 TVs, and in this 100 sets have defective picture tubes, 75 have defective sound system, and 80 have defective remote controls. 20 have defective picture and remote controls, 30 have defective picture tubes and sound systems, 15 sets have defective sound system and remote control. Now 5 sets having all the 3 defects, then the number of TV sets having at least one defect is. We can solve this problem by using Venn diagrams. So let us draw the Venn diagram here. And let us go from the last, that is, here what is the last sentence given? 5 sets had all 3 defects, and let us take the first one. N of P is how many are picture tube defective? 100. And second one, sound system we are taking, that is N of S we are taking. Sound system is of 75, and N of remote control failures are R, and that is nothing but how many we have? 80 we have. Now let us going from the last sentence. 5 sets has all the 3 defects, that is the common part of these 3 is nothing but 5. And 15 sets have defective sound system and defective remote control. So the common part of this sound system and remote control is nothing but 15. Already 5 are fulfilled here, so it is nothing but 10 we can write. Totally it goes to 15. Next, still another sentence, 30 sets have defective tubes, picture tubes and sound system. So defective picture tubes and sound system, how many we have here? 30 we have. Already 5 are fulfilled, so this is nothing but 25. Next, 20 sets have defective picture and remote control. So combination of this is nothing but 20. Already 5 are fulfilled, so how many will be now? 15. So if we are going to count the total number of defective picture tubes is 100, already how many are fulfilled here? 25, 5, 15. Totally 25 plus 5 is 30. 30 plus 15 is 45 and remaining is going to be 55. Coming to sound system, 25 plus 5 is 30, 30 plus 10 is 40. Already 40 are filled, now we require 75, so the remaining are going to be 35. And coming to remote controls, defective remote controls, 15 plus 5, 20, 20 plus 10 is going to be 30. Already 30 are fulfilled, we require 80, so the remaining are going to be 50. Let us give all this some alphabets here. So A is equals to 55 and B is equals to 35, C is equals to 50. D is equals to 15 and E is equals to 25, F is equals to 10 and lastly G is equals to 5. Now the question comes here. What the question comes here? Number of TV sets having at least one defect. Number of TV sets having at least one defect is nothing but what we have to do here, we have to take the addition of all the digits inside the Venn diagrams. So number of TV sets having at least one defect is nothing but A plus B plus C plus D plus E plus F plus G also. So what the result is going to be? 55 plus 35 plus 50 plus 15 plus 25 plus 10 plus 5 is nothing but 195 is our required answer. So the option A is the, we can take here the number of TV sets having no defects. Total number of TV sets, that is mu is nothing but 1000 already given. The number of TVs having defects, from the last question we got is 195. So the number of TV sets having no defects is mu minus A plus B plus C plus D plus E plus F plus G is nothing but 1000 minus 195 is 805 and the right option goes to option B. We require here the number of TV sets having only defective picture tubes. So already from the Venn diagram we can take the value of A as the answer, that is 55. In the form of formula we can write A is equals to total number of picture tubes minus E plus G plus D is nothing but, we can write it as already number of picture tube is 100 minus E is 25 plus 15 plus 5 is nothing but 100 minus 45 is 55 and the option number is B. We have another question here, that is we have to find number of TV sets having defective sound system only. Even as previous, from the Venn diagram we can give the answer of number having defective sound system is nothing but 35, but in the form of formula, if we require the value of B, we can write it as N of Q minus the common parts E plus G plus F we can write, that is nothing but 75 minus 25 plus 5 plus 10 is 75 minus 25 plus 5 is 30 plus 10, 40 is nothing but 35. So the option C is our right answer. Here, that is the number of TV sets having defective remote control only. From the Venn diagram, the answer is going to be 50, but in the form of formulae, we can write C is equals to N of R minus D plus G plus F is nothing but 80 minus 15 plus 5 plus 10 is nothing but 80 minus 30 is 50, and here the option goes to A. In Venn diagram, we have to solve this problem. Triangle represents deserted area, rectangle represents cultivated area, circle represents electricity present, and square represent medical facilities. Now the question is asking for which of the following statements are true using Venn diagram. If you take the option A here, what is option A says? The total cultivated area has medical facilities. That means what it should be, the rectangle should lie in square, but even the diagram it is not possible, so A is false. Coming to option B, what it said option B, some part of cultivated area has electricity and medical facilities. Maybe if B has to be true, then there should be the region common to rectangle, circle and a square. And if you observe the region 5, it is common for all these rectangle, circle and square. So B is true. Option C we are coming. What is option C says? Every cultivated has electricity. So for that, rectangle should lie inside the circle. But if you observe the diagram, it's not possible. So this is C is also false. And coming to option D. What option D says here, medical facilities are provided only in deserted areas. So the square should lie inside the rectangle. But here the square is having a common with a circle also. So square should lie inside the rectangle with no common region. To the circle. So D is also false. So we can say option B is right here. That is, some part of cultivated area has electricity and medical facilities. Circles here, and each representing the basic requirement of a school, like transport facility, experienced faculty, big playground and good infrastructure. Now the question comes here to the region which represents a school with experienced faculty, infrastructure, good playground, but does not provide transport facility here. So we require the region where all these three present and transport facility should not be present here. So that means what we require the region common to circles 2, 3 and 4, but it should not be a part of circle 1. So if you search the Venn diagrams, the region K is present as per our requirements. So that is, in this K region we have experienced faculty, good infrastructure and a big playground, but not transport facility. So the answer is K here, that is option number A is the right answer. We have another question here, that is the region which represents a school with experienced faculty, big playground and having transport facility, but it should not have a good infrastructure. So if you search up in the Venn diagrams, that means what we require? We require the region common to circle 1, 2 and 4, but lies outside of circle 3. If you search up in the diagram, we'll find the region H like this. So we can take H region as our requirements. So we can take the answer H as, that is the option B is the right answer here. In the form of Venn diagrams it is given. Circle represents experts in Telugu, triangle represents experts in English, square represents experts in maths and a rectangle represents experts in physics. Now the question is, which among the following represents the students expert in both Telugu and maths? Here the students experts in Telugu represented by circle and maths by square. So we require the common region of circle and square. That is, if you observe the Venn diagrams, the region 5th is common. So we can say here the region 5 is containing, in the students containing experts in both Telugu and maths. So the option goes to C. We are finding another question here, that is, which among the following represents the students are perfect in English, maths, physics, but not in Telugu. So to get the students perfection in English, maths and physics, so we require the common area or common region of rectangle, triangle and a square, and we don't require here a circle. So the area here represented by 7 is the common area of a rectangle, triangle, square, but not a circle. So the option A is the right answer. Of a survey of using calculators. In the question, 43 people will use Casio, 23 people will use HP calculators and 24 students with TI calculators. Out of this, 16 Casio and TI, 12 HP and TI, 13 Casio and HP, and 3 people uses all. And out of this, one is not going to be used anything here. Now we require how many of them are going to be used only Casio. So for this we require a Venn diagram compulsory. So let us take the Casio. N of Casio is given that 43 and N of TI company is 24, N of HP company is 22. Now let us take all the three, which are all who uses all, that is the number 3 will use all. In the question it was given wrong, that is 3 will use total 8 people. So we are taking the 3 as who uses 3 is 8, and coming to the next 13 Casio and HP. So Casio and HP will be totally 13. Out of this already we wrote 8 here, so remaining are going to be 5. Next 12 will use HP and TI. So already out of this how many we used? 8 we used, so remaining 4 are there. Next coming to 16 will be Casio and TI. So 16 out of 16 we wrote already 8 and now 8 are present. Coming to N of C. So how many use only Casio? Only Casio means the persons who use only Casio can be written as here. That is N of C minus 8 plus 8 plus 5. Nothing but 43 minus 21 is 22. So here we can write 22. And remaining here, out of 24, 8 plus 4 is 16, 24 will be here, and here 4 will be there. Now we require only Casio, that is already we got here, that is 22. So the option B is the right answer. One more question is given here. How many use at least one of 3 calculators? So for that, depending on the Venn diagrams, all the numbers we have to add here. We require the persons using at least one calculator. That can be given as A plus B plus C plus 8 plus 8 plus 5 plus 4 is nothing but 22 plus 4 plus 5 plus 8 plus 8 plus 5 plus 4, and the answer goes to 56, which is option number A. In a college is 10,000. So that is, we can write it as mu is equals to 10,000. Out of this, 40% of the students opt for electronics. So let us assume electronics as A. So N of A can be written as 40% of 10,000, that is nothing but 4,000, and this is for electronics. And next, given that 20% of the students opt for communications, let us take this as some B. So N of B is 20% of 10,000 is nothing but 2,000, and here are, these are for communications. Next, given also 10% opt for computers. So let us take computers as C, that is 10% of 10,000 is nothing but thousands for computers. Still, what is given here? 5% of the students opt for both electronics and communications. So we can write N of A intersection B, that is 5%. 5% means half of 10%, nothing but 500. And 30% of the students opt for communication and computers. This is nothing but, maybe it is 3% in the question. So 3% of the students opt for communication and computers, that is N of B intersection C can be written as 300. And still given that 4% opt for electronics and computers. So N of C intersection A can be written as 400. Lastly, what is given? 2% of the students opt for all the three. So that is N of A intersection B intersection C can be written as 200. Now we require the students opting only electronics. So we can write it as n of A intersection B bar intersection C bar. And this can be written as B bar intersection C bar can be written as n of A intersection B union C whole complement is nothing but we can write it as n of A minus n of A intersection B union C. And it gives the principle n of A will be as it is, and next n of A intersection B union A intersection C. By distributive law we are writing this, and this can be given as n of A minus n of A intersection B plus n of A intersection C minus n of A intersection B intersection C. Actually n of A is 4000 minus n of A intersection B is 500 plus n of A intersection C is 400 minus 200, and it gives 3300, and the option is B here. In the same sequence we are getting another question on the above question. The number of students who don't opt for any of these A, B, C. So that we can write it as n of A intersection B intersection C, nothing but A dash intersection B dash intersection C dash. We don't require any of these three. Can be written as n of A union B union C whole complement. And the formula can be written as n of mu minus n of A plus n of B minus n of plus n of C minus n of A intersection B n of B intersection C minus n of C intersection A plus n of A intersection B intersection C. This is nothing but 10,000 minus, in the bracket we'll get 4,000 plus 2,000 plus 1,000 minus 500 minus 300 minus 400 plus 200. It gives directly the answer 4,000, and the option A is the right answer.